Hi everyone. I think we're going to get started. We're running a bit behind the schedule, but that's what it's like at these sort of events. I mean, it's the first time we're hosting the Kafka meetup at the Data London, so new experience for everyone. Hi everyone. My name is Richard. I run OSO. We're a Kafka consultancy, and we manage. We host these Kafka meetups. So some of you are long-time members, some might be new, so welcome. So today we've got two great talks. We've got Quix in the house and Airspike, and obviously the theme is about fast data. So we're going to be now obviously streaming, so that should be really good. I'll hand over to you, Tim.
Great, thanks everyone for coming down. It's been a long day. I've been on booth duty, so you're probably all as tired as I am. So Dr. Streamlove, can I have a show of hands who gets the reference? Yeah, of course. Oh, wonderful, yeah. I did this talk in Germany, and like two people with their hands up in a full room. That was a bit unnerving. So I'm not Dr. Streamlove. Sorry to break it to you. I'm wearing an I Love Kafka t-shirt, so I get why people might think that, but that's not who I am. Who I am is this. I'm the VP of Data at Quix. I've spent a lot of my career building teams and building products in high-growth startups. I have a data engineering background, so I used to code a lot. I code a bit less these days, but Python, Scala, Spark, Kafka, those are my tools of choice. I spent the last 3 years or so in analytics land, so the modern data stack. You'll see some motifs around batch processing that I'm going to be mentioning. And since being a head of data and VP of data, it's all about data strategy, helping companies figure out what to do with their data. Areas of interest, real-time data ecosystem. So I just love, this whole thing with LLMs and vector databases, all the things that are complementary to like a streaming platform. I'm new to DevRel. It's my first professional DevRel. So I've kind of been doing it unofficially in teams. I think we all have. So I'm really glad to be exploring that space. And I'm a fan of less is more. I think we tend to overcomplicate things when we design systems and look for meaning in our life. And I feel that if you keep things simple and grow from there, that's the way. So for those of you who put your hands up, you'll recognize this. So the reference actually is from a Stanley Kubrick film. It's called Dr. Strangelove, or How I Learned to Stop Worrying and Love the Bomb. It was well known for its set design, so it's pretty iconic. I'll flick through a few photos. So it was all about good design, and here's Stanley Kubrick here as well. And here today, I want to talk about different design patterns here around streaming, and hopefully it'll inspire you to think a bit more about what they were thinking about back then when we were building real things. So, as I mentioned, I'm from Quix. So what is Quix? Quix is a brand new word. It didn't exist before the company. I think one of the co-founders just came up with a word. They were like, the sounds you make with your mouth, just buzzing sounds, I think. And then they came up with Quix. And what are we? We're a single tool that helps developers who are Python developers develop and run applications in real time. This is kind of like what Quix looks like. So we've got sources on the left, destinations on the right, and in between we are handling the processing, handling the monitoring, and so forth. And you'll probably recognize some of the logos there. So we've got like Kafka at the bottom there. We've got Docker. We've got Git. And this is how Quix as a company breaks down. We've got the open source part of our business, which is QuickStreams, which belongs to the community. It's an open source library for processing in pure Python. So I think quite a few of you here are familiar with Kafka. The whole landscape and ecosystem in Kafka land is largely based in Java and the JVM languages. So Quix's mission is to put Python developers first. So, naturally people who work with data, put them at the center of it and give them a library that they're familiar with. So we're highly inspired by pandas, or know what pandas is. And we're also a SaaS platform. So if you love to concentrate on the code and you don't want to worry about infrastructure, we provide that platform. So you can run your QuickStreams applications on our platform or run it yourself if you have a platform team and can deal with Kubernetes. Let's do this. Cool, okay. So Quix has an F1 racing background. So those are the four co-founders. It's Thomas, Peter, Patrick, and Mike. Mike's here. He's over there having beers. This is to scale. Mike's a very tall guy. I think he's about like 5 meters behind everyone else here. So he sticks out. And the roots were in real-time data processing in a highly critical environment. So low latency was really important. So every time a car goes around a track, they need to gain about 1/10 of a second for each lap to gain that competitive advantage. If you don't get that 1/10 of a second each time, you're on the road to ruin. You're going to probably start losing these races. So, highly critical data analysis in real time. 300 onboard sensors in each car. So they are creating 50,000 derived parameters and channels per car, and 1,500 parameters per channel per second. So that's a load of data flowing through the system. And they use that to perform simulations. So they can kind of start predicting how a car will handle on the track in the given conditions, the weather conditions, and start tweaking the car every time they pit. Is more racing background. This is probably why I was actually hired. I'm not a great speaker. I'm okay at data, I guess, but I'm really good at driving fast cars. So that's an F3000 on the right. It's a pretty fast car, and I love a track day. So that was the real reason why I was hired. So let's move on to batch or stream. This is a question that a lot of organizations struggle with. So it's really an adventure that you're going to go on next. I think most of you here may be familiar, but I'm going to just walk you through what batch is. So I'm going to take the example of a sensor on a cyclist. There's a cyclist at the top there, and the sensor is going to measure gravitational force. So we'll do it in 3 dimensions, so X, Y, and Z axis for G's. And how batch works is you're processing data at rest. So you've got data that's collected over time into a database. So that cylindrical thing in the middle, that represents our database. And so if I advance, we're going to see some data points being created. So we're now collecting into that database that first data point. A short time later, that cyclist is somewhere else. We collect another data point, and so forth. So now we have 4 data points in that database. So that's one part of batch. The other part of batch is to process that data. And we call it bounded data because it has a start and an end. So what we do next is we process that data. And we do that by grabbing all the data between 2 points, between time 1 and time 3 or time n. So it has a start and an end. And then you process that data. So in this case, we've processed it, the X, the Y, and the Z, and we've summed it to get a total of the gravitational forces. And then you can figure out deltas. And that's how that works. So streaming is a little bit different. So the mindset for this is different. Again, it's kind of like 2 components. The first component is that data is collected over time into a transport layer, like a broker. In our case, it will be Kafka and into a topic. So let's get the cyclist going again. So that's the first data point, except that the data is processed immediately. So the processing system is continuously consuming this data, and it's unbounded. So we started off at time 1, and now we're going to get continuous data points. They're unbounded. They'll keep going on forever. So from that, you can derive the total again. So you add up all the X, Y, and Z, G values, you get the total. And then you have a stateful store, which you keep to keep track of what the values are. Again, cyclist moves on, creates another data point, time number 2, and so forth. So you got new deltas, and then you apply that to the existing state that you're keeping. So that's like conceptually how streaming works. You compute on each event, and you keep the necessary state going. And that means you don't have to keep all the historical data. You're calculating as you go. So most importantly, real-time results. So the batch mindset is this. You're waiting for data. You're slowing things down, and you're introducing a delay before you process the data. Idempotent. So given the same data, you expect the same transformed result each time. Who's seen a batch job fail? Probably everyone, right? And they fail a lot often too, like when you get to large-scale data. So you just know that because you've got a start and an end. If you rerun that again, throw more compute at it, throw more memory at it, it'll probably pass, and then you'll get the result you want. And that's kind of like the mindset you approach batch with. And most importantly, there's time to fix it. So things do go wrong. That's cool. We'll just roll back. We'll rerun jobs. Hopefully it'll work this time. That's kind of like the mindset. There's a lot of hoping and praying. Stream mindset's a little different. You process that data now. So my belief really is that data is most valuable close to its point of generation. Like you've got to look at it once it's generated, and its value diminishes over time. and you want to capture all those changes. The fact that a technology like Kafka is an immutable log, it will keep growing, and as new events come in, it's a log that grows, that it's distributed, and it enables you to recreate that any point in time, because you just play back that log. So you have ways of doing that by rewinding in a stream, etc. And most importantly, this is the one that I found resonates most with people who are unfamiliar with streaming. You write once, and then you get to read an infinite number of times. It solves that distribution problem. So once you've got data into Kafka, you now have a central source of truth for your events, and now you can start arranging teams who are able to write consumers and come to the data. So data lives here, come to the data. Let's put that on a t-shirt. That's kind of how it will start working. So one of the reasons the stream gets no love, I'm really proud of this next one. You can see some memes, by the way. This is original content. And this is like, when I sat down, I was trying to remember all those times I tried to introduce streaming into an organization. And I thought, right, if I had to do one push-up every time someone said no, I'd be swallowed like that guy right there. And the problem with real-time requirements are, people in organizations, they're not really trained to gather requirements properly. Like, I genuinely had one like this, in a joking way, but as a business user, I want real-time updates. And I want the real-time things all the time. So they have absolutely no idea what they actually want. And so when you get a request like that, you say no, because it's just nonsense, right? But what you start learning is that what that user actually wants are things like predictable refresh rates. They want to be able to look at the data at a point in the day and just know that that's real, know that it's been updated, know that you can trust it and make action and take actions from it. And you start thinking about SLAs, so service level agreements. You think about the promises that you're going to make to your customers, or stakeholders, or people who are going to be looking at your dashboards. Like you want to make these promises and say, we're going to deliver this by this time, guaranteed, so you can do your job and you can trust us, and life goes on. And here are a few use cases to kind of explore what the real meaning of real-time requirements are. So, everyone's hopefully used Amazon or an e-commerce store. Like when you've tried to buy something, a lot of fraud prevention algorithms are running over your data points at that point, and they want to figure out if it's a fraudulent transaction or not. If it takes too long, you're going to get annoyed. So that's an experience you're going to design around, and you need to have SLAs in place for that. Weather simulation, another one. So if you're simulating the weather over an hour, you want to make sure that simulation runs in time so that you're not waiting beyond that hour, because that'd be nonsense, because you'd be behind there. And lastly, in field robotics, you've got robots out in the field moving around, especially around humans. You definitely don't want them to hit anything. So that would be the SLA. It's like the latency has to be enough that you can detect and not hit the thing. And this is kind of like a paraphrase of the kind of pushback and resistance I get when we talk about streaming in organizations. So I'll read it out. If a pipeline is not a tangible threat in terms of overload for the stability of our databases or the infrastructure itself, most of the time we get away with pushing data in batch mode to achieve near real time. So they'll micro batch it. They'll just batch it at a much higher frequency. And this represents about 99% of people. That's the first thing they'll do, and that's really the right thing to do. And the reasons for resistance, so I'm going to list out a few of those. The ones I see are, it begins in college and university. Streaming is not normally taught, or it's an optional module. And I've seen that changing over time now, even in the past couple of years, it started being taught, and it tends to not be optional. But at least, students are learning, that's good. It's habitual, so again, when you have absurd requirements, you're going to push back. And so you're just used to pushing back, there's that streaming discussion again, I'm just going to say no. So you form a habit, and that's what we are, we're creatures of habit, right? You might have lots of historical data. You might say, well, we don't really need to deal with streaming. We don't care about the current data. We like a lot of that historical data. We need to just aggregate that, and that's just what we need in our business. The ordering isn't important. So tools like Kafka are really great for guaranteeing ordering. You might not care about that. You just care about snapshots. You care about things happening at a moment in time, and then that's it. You don't really care about anything else. I keep getting told, it's the abstraction of the stream. It's not quite easy to grasp, despite best efforts to get it understandable by using concepts like tables, and if you're using R and pandas, the concepts of DataFrames. So they're very much table-like concepts. And then, yeah, this is the second one, the lack of skills. You've got to start with building that knowledge and acquiring these skills. There's been a lot of investment in data and real-time streaming. So, some of the companies are represented in this room, and that education is such a good thing. Like that was largely missing, like maybe about 5 years ago, and now it's like building up more and more. So I think more eyes are on it. So reasons to love the stream. Here's another quote: "The data's too fresh. I need to slow it down." Like no one ever said that, right? Hands up if someone said that to you. No, didn't think so. So no one ever said that. They never need to slow the data down. So here are the reasons to love the stream. You got better integration. Again, you've got that decoupled reading and writing. So you have data somewhere, and everyone goes to the data. No more waiting, so you don't have to burn compute by polling something to check if something's arrived or not. We've all been there. You don't want to do that. No micro-batching, so no forcing batch to work to your time limits. Fault tolerance as well. So with broker technology like Kafka, you get the durability. That is, like, you don't get any data loss. You get the high availability. You get all of that in the product for free. And the consumers, you read out, you can have these concepts of consumer groups, so you can work in parallel on streams of data and process them in a timely fashion. And then guaranteed ordering. Let's say no more about that. I mean, it's just great to get things in the right order. And here are the signs that you should love the suite. First one, increased latency. So, the requirements keep coming in. We need that data faster. There's a limit with batch. So when you see that curve growing in latency, you know where it's headed. Frequent batch jobs, like running. I've seen the same batch job even run on the same set of data in duplicate, because they thought, right, well, one of them has to finish first, right? That kind of thinking doesn't quite work. I've seen that done. Increased landing times, again, like you need the data to land at this point in time. It just keeps getting later, and as time goes on, later and later and later, you know that you're going to start breaking those SLAs. Data for events. So events in this case are live events. So if you're running a Black Friday campaign, if you're an e-commerce store and you want to offer promos, especially if you want to do kind of tailored coupons based on user activity, you've really got to start thinking about streaming. And I mentioned consumption patterns. That's one that works a lot. No more polling. You go to the data and you consume it as and when it's ready. The last one's building Amazon Go. Has everyone been to an Amazon Go? There's a few of those. Hands up if you've been in Amazon Go. You tried the shopping. One person. Wow. Good thing I've got this next slide then. So you want to build the art of the possible. So what Amazon Go is, it's walkout shopping, something that they've patented. So you literally sign in with your Amazon account with a barcode. You go into an ordinary supermarket and you lift things off the shelf and you put it in your bag. And then you walk out. And no one comes after you. And that's walkout shopping. And you can see the kind of value that it creates. 85% increase in value just on that move alone. So pretty awesome. So batch and stream perhaps, because we've identified some use cases that could work for batch really well. Got a lot of historical data that could work for batch. Need some real-time experiences that we need to build. Could work for stream perhaps. So this is philosophy that I follow, that we live in an and world. Like I live in an and world. I don't live in an or world. Like you can have the things. You don't need to keep choosing all the time. It's just tiring anyway to keep choosing. Just say yes when next time someone says, do you want this or that? Just say yes. It's just easier. How many of you here flew long haul? Okay, some of you flew long haul. We've all been on a plane. What's that question we keep getting asked when the trolley comes round? Chicken or fish, right? Can't have both, okay. And then when I was in school, I had to choose between Spanish or French. We've got all these choices to make. Again, I had to, as a kid, choose, do I do art, do I do photography? And the one I dislike the most, ice cream or cake. Now, that's a crazy question to ask me, and I think for most people here, it just doesn't make any sense. So what's the world we want to live in? We don't want to live in this stressful world when you have to choose between batch and stream all the time. The real answer is both. So we live in that world, we live in that and world, and identifying the right tools for the job and putting them in place. That's what we have to do more of. So I'll briefly go over some of the architectures that can enable batch and stream to kind of work together. This is one that Nathan Mars coined called the Lambda architecture in 2011. You've got a data source coming in, and you kind of, in duplicate, create a real-time layer and a batch layer. So you've got real-time queries coming in on the right. You've got batch queries coming in on the right there as well. And you've got some of these mixed ones that need best of both worlds. I don't recommend this one, mainly because you've got two code bases. You've got to synchronize them and coordinate the releases. That's a lot of overhead. You've got to use the same algorithms in both places. Otherwise, you're going to get weird drift. And where do you read from? If you've got batch delays, should I go to the speed layer? Like, what do I actually do there? It's not always clear. And of course, double the infrastructure, so double the fun there. One I do recommend is something closer to this. There are many architectures, I'm speaking broadly here now, but something with a Kappa architecture where everything goes through a real-time layer and you start syncing it to storage. That just makes more sense to me. So now you've got your real-time app, which has its own storage and stateful store processing, and you've got a batch app, so you can handle analytics workloads, you can handle real-time experience-style workloads, experiential ones on your Black Friday. And the other reasons why: single core technology stack, single entry point, so much easier. Data in one place, single source of truth for events. Super easy. Simple. It's in real time. You can recreate state, like I mentioned, and improve data quality. You've got these things called schema registries, which are a wonderful thing that enable you to validate data automatically as it comes in, because you always have to have the schema alongside the data. And this is a really significant one. You don't need to re-architect. So once you start off with Kappa architecture, you automatically get the benefits of both. You don't need to re-architect somewhere down the line to say, right, we need to build real-time experiences. You kind of get it already. And so this is like the mantra we live by. The future of data is real-time. Who is seeing this? Earlier in the year, Matt Turk created this ML AI data landscape called the MAT landscape. And you can see like all the tool providers, some of whom are represented here on there. And if you zoom into what the streaming market looks like, this landscape's kind of like this. You've got streaming platforms, so you've got a few people in the room here from some of these companies. You've got CDC, connectors, ETL, Stateful stream processing, lakehouses, real-time OLAP, streaming graphs, streaming databases, so many more. And that list just keeps growing, like additional investment going in all the time. I'm a bit biased, that's who we are, just in case you missed us. So we get to the take-home actions. I'm going to keep this really simple. Consumption. Like I mentioned, this is how most people grok in, really understand the benefits of streaming. Think about where does data need to appear, and make away with all the stuff like the polling. Like you can start getting this data into the right places at the right time. Make a plan. Think about your requirements in the business. Like don't just idly take data as it comes. Think about what you actually need and how it benefits your product. So think about service level objectives and agreements. Figure out how much latency is acceptable. And lastly, like with Amazon Go, that wouldn't have been possible without imagination. So imagine what it would look like with real data. That's the world we want to build in the future. We're never going to get that with batch. So those are the take homes. I like to always end, because I'm on the last slides now, I like to always end on a quote, a powerful quote. This is from one of my favorite philosophers. So yesterday's history, tomorrow is a mystery, and today is a gift. That's why we call it the present. One of my favorite philosophers, Master Oogway, who is of course from Kung Fu Panda. So hopefully this has inspired you to go revisit your organization, the things you're doing with data, and to think, right, how cool would it be to live in the present? And you start designing for that, and then we'll build a beautiful future. And you too will finally have inner peace. Thanks very much. Yeah, we can do that. Yeah. I'll just do that.
Thanks, Tom. We've got any questions? We've got a couple of prepared if no one has any. Yeah, you've got one? Okay.
Hi, cool talk. So when you approach your customers, do you approach customers who use batch and try to convert it into stream, or do you approach customers who already know that they need stream?
So you're doing that as well. You're living in an all world. Do you convert them? It's not really a conversion. It's just like you have to keep batch. I say favorite, but my favorite customers are the ones that say, great. So we're gonna bring in Kafka. We're gonna bring in streaming technology. Awesome. So now that we've got Kafka, can I get rid of all these other databases that I have? Like, they misunderstand. So it's really about educating them in the use cases. So really emphasizing the use cases there. You don't want to get rid of what you have because that's working. What you will do is you will unlock new possibility, new use cases, new product, new revenue. Everyone loves money, right? So depending on who I'm talking to, I'll speak to them at that level. So really, it's about unlocking new use cases. Like no one sees the possibility. Like Amazon Go should not exist or shouldn't exist, but someone made it exist with a blend of computer vision and real-time data. So it's really about the imagination. And as you grow up, you kind of lose that, right? So you got to spark it. You go on holidays. Some people go on meditation retreats. Some people go on silent retreats. You figure out that way to do it. And so I'm trying to tap into that and say, well, if you could do anything, what would you do? Right, what's the world you want to live in? So I kind of start there. Hopefully that answers your question. Thank you.
This may be a bit of a weird question, but you said there are like 300 sensors you put in the car to evaluate analytics. So do you evaluate whether it slows down the car to the 300 sensors in terms of weight? Like, do you assess the usefulness of all those sensors? And is there like a number where it makes sense to stop because it just slows down the car? I know it's a random question.
Yeah, definitely not a funny question when it comes to a critical F1 environment where you're really trying to be the fastest and seconds count. Because like really, a few milliseconds is meters, right? Meters on a track. So that's like the difference between coming first and second. And no one wants to come second, right? When you've invested all that money and all that training in. 300 sensors, that's a number I keep hearing from the co-founders. And like I've confirmed that with like some other people as well. It's roughly around 300. It's in excess of really. So they actually have more sensors these days. What's more important is just like from those sensors, like a single sensor, like in the example I gave you, like gravitational pull, that, for simplicity, generating X, Y, and Z. So you're generating more values from it. So yeah, then the number's closer to like 50,000. Like those 300 sensors get you 50,000 data points. And when you're talking about ever-changing things like the weather, a big one actually goes up to like something like 4,000 data points per second when a driver takes a corner really fast and has to brake, because you're now capturing downwind, different forces, the angle of the spoiler. There's like lots of things that are happening. The torque on the car. So. This is like, in an earlier talk, I talked about how you've got to measure what matters. Don't just measure everything. This is the exception, I think. Just measure everything, because we know they need it all, actually. They use it in some way. And when you have really mature models that can deal with that many parameters, like in MATLAB and in machine learning models, you figure out the pattern so much faster when you have those data points. But yeah, really good question. Thank you.
Yeah.
One of the things that I think that Stream provides that micro batching doesn't necessarily provide is the ability to have something happen instantly when something else happens. And I just wonder to what extent Stream, do you see it as a data product or do you see it as an automation or business logic product? Because, I guess that's my question.
Yeah, it's an interesting one. You want certainly the Quix way, if you understand classical data integration patterns, if you're familiar with pipes and filters, it's basically something goes into something else as the input, which has an output, which feeds into something else, so it's continuous. In our world, the pipelines are essentially, the mesh is the Kafka topics. So you're reading from a topic, you're processing it, you're writing it back out. And you're doing that continuously. So you have like a chain or like an acyclic graph of that. At each point, you can tap into that and take that data. So you can react on anything as it's changing. I usually say don't boil the ocean. Like when you have processing and you want to do some cleaning up, don't do all the cleaning in one step. Stage it in have it in different stages. So the first stage may be just filling in all the nulls, for example. So you impute the values, the missing values. The next one might be, we need to get it to fit closer to this schema or to these enumerations that we've defined. So you want to do that. So you're increasing the surface area for enabling things to happen as a result of other things. Because when you build up that pipeline, you've got downstream providers who care about more clean data. And then you have data scientists who care about something closer to raw, because they're going to just, do feature engineering on it anyway. So they want all the parameters. So it's a bit different. From an event-driven perspective, yeah, that's exactly what you do. You, if you're familiar with, event sourcing and that command principle, how all of that works is the same thing. It's just like you have things come in, you react on them, and like this is just a reliable way of doing it. Yeah. Did that answer your question? Follow-up question?
Any more questions? No, cool. I think we'll take a 10-minute break, have a few beers, and then we'll pick up the next topic as well.
Nice, thank you.